So I got my package in the mail a few days ago and decided to do a little unboxing video. This is a color factor set, and it was created by Seton Pollock in the early 1960s. And it's a structured approach to mathematics that encourages children to manipulate materials rather than just tackle abstract concepts. I'm really excited to unbox it. They're similar to Cuisenaire rods, but Seton felt that he had improved upon Cuisenaire rods. So I'm going to unbox it and we'll have a look and see. I'm quite excited. It's not often you come across an old set like this. Hopefully I can do this. And here it is. It's a really old box. But old does not mean invaluable. I opened it up the wrong way. So here it is. Has the smell of an old box as well. This one came from England, 72 London Street, Reading, England. This kit's older than I am, and you can see that by just looking at the box. I mean, it's quite old. So I'm going to put the lid to the box underneath and then slide this up. Okay, so here we've got the centimeter blocks. This is the first one, and the second one, if we go up in size. Hopefully you can see these. I'm pretty sure that's okay there. I'm just going up by 1 unit each time here, making a little staircase. Now these are similar to Cuisenaire rods, but they are not exactly the same as Cuisenaire rods. One, the similarities are that they're rods, and they're based on centimeter cubes, though they don't necessarily have to be centimeter cubes. They could be bigger. It's the colors that are more important, and the fact that, you know, if this was 1, then this one would be 2 of those, and 3 of those would fit in there, and 4 of those would fit in there. That's assuming that we're letting that be 1. It could be 100, and then that would be 100, 200, 300. It could be 1,000, and that would be 2,000, 3,000. It doesn't really matter what this is. It's the relationship between this and each of the others. And the fact is that 2 of these fit in there, 3 of these fit in there, right? So it doesn't really matter what this is. But if we allow this to be our 1, then you can see that this goes up to 12. There's 12 of these little white ones would fit in here. So these ones here, this kit is based on primes and the power of primes. So we would look at this as 2, which is the prime, the power, sorry, 2 to the power of 1, and then 2 to the power of 2, and then this one would be 2 to the power of 3. And I don't know if you notice anything with the colors there, but the intensity gets deeper. And if we kept going, this would end up going into darkness over here. And also this is based on the primary color red. So then if we look at the prime yellow, or sorry, the prime yellow, the prime number 3, This would be 3 to the power of 1 if we put it to a power, and then this would be 3 to the power of 2, which would be 9 of these fit in there, 3 of these fit in there. And again, the intensity of the color it deepens, and again, this would move into darkness. And let's see, let's put this back over here. Yeah. Okay, then we've got 5, which is a prime number. Okay, and we don't obviously have 5 to the power of 2, a 2 block here, but you can imagine that if we did have 5 to the power of 2, that again the intensity of the color would deepen and eventually would go into darkness. We've got composite numbers, which are, this is not prime, but it is built on a prime to a power, right? So it's built on this being prime number 2, and this is 2 to the power of 1, and then this is 2 to the power of 2, which gives us that. Same with 8, it's not prime obviously, but it's based on a prime. And same with 3, that's prime. This is not, but 9 is based on a prime number to a power. So then if we look at the composite number 6, it is based on prime number 2 to the power of 1 times 3. And there is something to be said with these two colors and this here. I'll let you kind of figure that out yourself. And then if we look at 10, we've got 5 to the power of 1 times 2. And again, you can probably see some relationship to those colors there. So this kit here, the color factor set, was named the color factor set for a reason. It is based on the primary colors, red, blue, and yellow, and intensities of those prime colors and mixtures of those colors together. And this doesn't really, white doesn't really change the intensity of any of these colors, but all of these could be times by, this one here, right? 2 to the power of 1 times 1, right? So it's an interesting set. I just got it. I've not really played too much with it at all, other than what you've seen right here. But I'm learning a little bit about it, and the more I learn about it, the more I will share with you about it. Let's just look at even numbers. Let's do the even numbers. 2, 4, 6, 8, and then 10, and then odd numbers, 1, 3, 5, 7, and 9. Is there any relationship between those colors? I'm going to leave that to you to think about. There may be, there may not be. Oh, we could also put 11 in here, and then we could put 12 in here. Just take those out because I've got doubles. So think about that. One of my students, when playing with the Mortensen math blocks, noticed some differences between the colors when we were building an odd Christmas tree versus an even Christmas tree. So it's something to think about, the colors, and why do these blocks have colors, and do they make any sense? These blocks can be used to teach many different mathematical concepts, from basic arithmetic to algebra, to sequences, a little bit of calculus, trig, Pythagorean theorem, which, I guess technically is a little bit of trig, study of triangles, right? Although that's really kind of the study of squares and triangles. You can do so much with these blocks. If you want to look at this as your 1, this would be the 11 block here. If that's your 1, well, how much would this one be, right? Well, that's 5/11ths, right? If this is your 1, then that actually becomes 5/12ths, right? And if this is your 1, well, then that becomes half, right? And I should really put these on top, the smaller one on top. So when I was looking at this, because we should really match it to this, the model to the symbols. So 5/11ths, and then 5/12ths, 5/10ths, right? Or 1/2. And another way of doing 5/10ths would be like to have 5 of these little ones out, so you could see 5/10ths is the same as 1/2. All right, so fractions, right? If we were talking multiplication, we could say, well, you know, we've got 2, 3, 4, 5 of these. Well, 2 counted 5 times is the same as 10, right? And I would do this, to be honest, to start. We're counting 2 5 times. 1, 2, 3, 4, 5. And then you could lay it out like this to see, well, how much is that? And then that there actually creates your same as sign or equal sign. Or you could say 10, how many twos can I count from 10? Well, let's find out. 1, 2, 3, 4, 5. So that's division, right? You wanted to do some simple algebra, you could say, well, I've got 5 plus some numbers the same as 10. Well, what does that number have to be? Well, that's going to be another 5. So 5 plus x is the same as 10. We could talk about subtraction. We could say that we have 10 and we want to take 6 away, or we want to talk about the difference between 6 and 10. Well, what's the difference between this and this? Well, the difference between that and that is going to be this here, right? So addition, subtraction, multiplication, division, basic algebra, so much that you can do with this, you know. You could build triangles, a 3, 4, 5 triangle. So there's a 3, 4, and which one is 5 in these blocks? That's not 5. There's 5 here, a 3, 4, 5 triangle. So Pythagorean theorem. We're talking about that, right? And you've got your 3 square. And your 3 square and your 4 square is going to be the same as your 5 square. Right? And we can actually show that. So this square plus that square is going to be the same as that. I always like to put a little unit block in there to show that it's a right triangle. This is not exactly perfect here, but it'll give you an idea. And then we can put this on top here. And let's see if it's the same. And this was just our little right angle. And you can see that a 3 square and a 4 square is the same as a 5 square. And you take that off, there's your 5 square, and that's the same as a 3 square plus a 5 square. There's so much math that can be modeled and played with using these blocks, Cuisenaire rods, easy math blocks, Math UC blocks, Mortensen math blocks, even just regular base 10 blocks. I'm a big fan, period, of base 10 blocks because there's so much math that you can do with them. I do prefer, though, the multi-unit base 10 blocks like these, where rather than having 2 of these, you just pick up one of those, right? Rather than having 3 of these, you pick up one of these. So it's a multi-unit block. This is a multi-unit. It has 3 of them. This one has 2. This one has 4, this one has 5, and so on. So the multi-unit blocks allows you to do so much more, because here you can see that you've got a 3 square and a 4 square. And it's the same as a 5 square. You know, or you can see that 3 and 4 is the same as 7, right? So having these multi-unit blocks is really, really useful. Anyways, I'm pretty excited about this kit. I'm going to be playing around with it a lot, just like I have with the Cuisenaire rods, and I hope to become fairly proficient in my knowledge of them and share some of that knowledge with all of you. So like I said, this is a very rare kit. There is an occasion that you can find one. I did get lucky and I did find one, and I'm very super stoked. This was kind of like my Christmas gift to myself. I do celebrate Christmas. No, not everyone else does, but I do. And I did not actually celebrate Christmas as a kid. So I guess perhaps maybe I get a little more excited about it as an adult. And this was basically a little bit of a selfish Christmas gift to myself, but not really selfish, because I get to share it with you by doing this video and showing you just some of the really neat stuff that's out there, that's been around for a very long time. And luckily for me, this kit is in incredible shape. These blocks, you would not know they are 58 years old, because this kit was made in 1962 based on what's on the front of the box. You would not know that these blocks were 58 years old. I did come across one other kit like this, but the blocks looked like they'd been water damaged. They did not look in good shape, so I didn't purchase it. I came close to it, but realized that the blocks were just in really bad shape. So I got super, super lucky. And I'm really grateful and thankful that I actually am able to have one of these kits developed by another very mathy guy, if you want to use that as a term. Someone who really wanted to help kids. Not to mention, this also has to do with not just the colors, but also musical notes and things like that. So there's some real neat stuff to learn from this old stuff.